Section 7.6 deals with tree diagrams. We're still talking about probability, but we're looking at a different way of recording probability and checking probability. In Section 7.5, we looked at the probability of an event or a single event happening and what the probability of something in that event happening would be. In this section for 7.6, we're going to be looking at tree diagrams and how to record the outcomes or the probability of outcomes taking place when there is more than one event. In the first one, we looked at flipping a coin or rolling a dice. Flipping a coin, there are only 2 possible outcomes, whereas in rolling a dice, there are 6 possible outcomes. 2 things to remember to start is that whether you roll a die or dice or flip a coin, the outcomes are equally likely. You're as likely to roll a 1 as you are a 4, and you're as likely to flip a heads as you are a tails. There isn't a higher probability in any way. But what we're going to look at in terms of tree diagrams, we're going to talk about independent events. What is an independent event? An independent event is if the result of one event does not depend on the result of another or the other event. If I roll dice, if I take 2 die and I throw them, and after I've rolled them, the first outcome or the first rolled outcome does not depend on what happens the second time I roll the dice. And the second rolling outcome does not depend on the first. If I roll 2 4s on my first roll, that doesn't mean that I can only roll 2 4s the second time. They're completely independent. When I flip a coin, if it's a heads, the second time I flip a coin, just because I got a heads the first time, doesn't dictate or tell me what I'm going to get the second time. They are independent events of each other. A tree diagram does help us to figure out the probability of what your outcomes might be from 2 independent events. So in this case, we're going to talk about flipping a coin twice. I flip it in the air once, I flip it in the air again. What's the probability that I can get a certain thing on the coin? The 2 questions we're going to look at to start are, what is the probability of tossing 2 heads or heads twice? And what is the probability of tossing 2 different coins? So if I toss one coin, I flick it, and I get a heads, what's the chance I'm going to get a tails, and vice versa? And we can check that using a tree diagram. Here I've mapped out with the first coin. When I throw a coin in the air, or when I flip a coin or toss a coin in the air, one of 2 things are going to happen. I'm either going to get a heads or I'm going to get a tails. And then once I've done that, 2 things can happen on my second toss. I could get a heads and a tails, or I can get a heads and a tails, dependent upon what happens on the second coin. The first coin, if I throw a heads, the second one I could throw a heads or I could throw a tails. Or on the first coin I could throw a tails, and on the second one I could throw a heads or a tails. So I have to list my outcomes. In this case, the possible outcomes are a heads and a heads and a tails then a heads, or a tails then a tails. So I have 4 possible outcomes here that I might be able to have happen if I tossed a coin twice. Now if I look at this, that shows me that I have, in this case, I have 4 possible outcomes here. And with those 4 possible outcomes, each one is likely to happen 1 time. So if I ask the question, what is the probability of tossing 2 heads? I look here. Okay, nope, that's got 2 tails. That has a tails in it. That has a tails in it. Only one of them has both coins landing on heads. So my probability of tossing 2 heads is 1 in 4, or 1 to 4, or the third way that we talked about would be if you put a quarter into a percentage, you get 25%. So for the first one, what is the probability of tossing 2 heads? I toss the coin once, I toss the coins again, I write the outcomes down. I could get a heads and a heads and a tails and a heads, or a tails and a tails. The probability of tossing 2 heads would be 1 in 4. And then I can look at it a different way, and I can ask myself, what is the probability of tossing 2 different coins? So this time I don't get two heads or two tails, each coin will be different. Well, if I look here, my first outcome is heads and then throwing a heads. Those are the same, so I can't use those. Heads and tails are different. Tails and heads are different. These two are the same, tails and tails. I still only have 4 outcomes, but this time I have 2 favorable outcomes for me. So that means I have 2 out of 4 or half. And I could write those in my fraction, in my ratio, and of course the last one in my percentage. 50%. Looking at my possible outcomes, the probability of tossing 2 different coins, so one being a heads and one being a tails, there are only 2 possible times that could happen. 2 out of 4 is a half, so 1 over 2, 1 to 2 ratio, or 50%. But there is something else you need to think about as well. There's 2 things called theoretical probability and experimental probability. Theoretical probability is that in theory, or by looking at the question, what is the possible probability of an event happening? So just by looking at this question, what might happen? And we went through and we found out what our possible outcomes might be. Just by looking at the numbers and ideas presented, what is the probability of an event happening? So what was the probability of 2 heads coming up? It was 1 in 4. That is theoretical probability. It's only a theory because we haven't actually done the experiment. The second way is experimental probability. That's by actually doing the events. What actual probability do you find? By carrying out the 2 events talked about, what probabilities do events have of happening? In this case, I have a 2 in 4 chance of throwing both coins and getting 2 different outcomes, getting a heads and a tails or a tails and a heads. I might take that coin and flip it once, twice, 3 times, 4 times, and I might find that I get heads and heads or tails and tails every time. So my theoretical probability of getting 2 different coins is 2 out of 4, but my experimental probability might be something completely different. I might get it 4 out of 4 times, 0 out of 4 times, 1 out of 4 times. It depends on what happens during the experiment. So theoretical is just by looking at the questions, what in an ideal world, looking at your possible outcomes, what might happen. Experimental probability is when you actually do it. So in this case, I set up a tree diagram for 2 different events. My first event is flipping a coin. My second event is going to be spinning a spinner. There are 4 different colors on the spinner, so I'm going to have 4 different possible outcomes for my second event. My first event is flipping a coin, and like we talked about already, it's either going to be a heads or a tails. It can't be anything else. There is no other side to the coin. You're either going to get a heads or a tails. But for the second event, the spinner, there are 4 possible outcomes. I could get a purple, I could get green, I could get red, or I could get orange. And the same thing goes for if I hit a tails. Purple, green, red, orange. I might hit a heads and a purple. I might get a tails and a green. It really, because they're independent events, you never know what's going to happen. So in the theoretical probability side of things, in theory, my possible outcomes would be a heads and a purple, a heads and a green, a heads and a red, a heads and an orange, and the same thing for tails. A tails and a purple, a tail and a green, a tail and a red, and a tail and an orange. So my theoretical outcomes here, in theory, I should be able to get 1 of 8 outcomes. Now, depending on how often that happened, it may not work out that way. We may find that in theory something comes up more often than not. So in this case, there are 8 different possible theoretical outcomes. So we're going to do an experiment really quickly. I am going to toss the coin and spin the spinner, and we're going to keep track over 8 flips and spins what my outcomes are. So first things first, I'm going to flip the coin, and I got a heads. I spin the spinner, and I get a green. So I got a heads and a green. And then I go back again, and I start the coin and I stop it. I got a tails, and yet again I got a red, so a tails and a red. And then we're going to do it 6 more times. Got a heads, and I'm going to spin the spinner. So I got a heads and an orange this time. I'm going to flip the coin again, and I got a heads, and I'm going to spin the spinner, and I got a purple this time, so I'm at heads and purple. And then I come back to the coin one more time. I got a tails, and an orange. So there's 5 events, or 5 combinations of events. I flip it and I got a heads, and I spin the spinner, and I got a green, and I flip the coin again. I got a heads, I got a heads and a green again, so that's the 3rd time I've got a combination of a heads and a green. And the last time that I'm going to flip the coin, I got a tails and purple. Tails and purple. So, in theoretical probability, I had a 1 in 8 chance of hitting any of these things. But when I went to do the experiment and actually flipped the coin and then did the spinner 8 times, I found that I got a heads. I got a heads and a green more than anything else. Some of them I didn't even get. I didn't get a heads with a red. I didn't get a tails with a green. I did get 5 other things once, but I found that my theoretical probability of getting all of those outcomes was 1 in 8, but my experimental probability was a lot different. Some outcomes I didn't get, some I got more than others. So what I want you to do today for your practice is pretend that this is a spinner. The pointer is spun 1 time. The color is recorded or written down. This pointer is spun a 2nd time. The color is recorded. For A, draw a tree diagram to list your possible outcomes, just like I've done here and I've done here. Find the probability of getting the same color. So what's the probability of hitting red twice, blue twice, or green twice? What's the probability of getting 2 different colors? And then for D, Karina and Paulo carry out the experiment 100 times. There were 41 same colors and 59 different colors. How do the experimental probabilities compare to the theoretical probabilities? And then explain your answer.